I just have to stay there. It's, oh well, I'll figure it out eventually. So in general, what does it sound like a population is? It's not a number, right? Because that's the size of a population. So in general, what's a population?
The group tested.
The group,
Tested.
or let's say a collection of things. It could be people, it could be shoes, it could be light bulbs, it could be stink bugs, I don't know, whatever I'm studying. Collection of things that I want to study, that I want to be able to say something about, right? Okay. So what's a sample then? Now that we've defined population, it's a little easier to define sample. What's a sample then?
Specific.
Where did our sample come from when we were doing the thing for the parking times? It came from the population. So once you define population, sample is easy. It's just the people you picked from the population, right? The subgroup of the population. Is that cool? That I actually analyze. I'm not going to actually analyze all of the population, unless it's a small enough population, right? Normally in statistics, what do we have to do? I want to say something about everybody in the United States. Will you vote for Mitt Romney? I don't have time to talk to everybody in the United States. So I have to get a smaller group from the United States, my sample from that bigger population. So this is the selected subgroup from the population that I actually analyzed. Sure. So the sample is the selected subgroup from the population that I actually analyze.
Can you give an example? Like,
So there's the one about, we want to say something about all the Grossmont students parking. So the sample would be the students that I actually talk to, or any of my team members. I get some of you guys to go to various spots, and whoever you talk to, the big list of all their answers, that would be the answers for my sample, right? So if I wanted to say something about the average number of times people are bumped from American Airlines flights, who do you think my population is? What about American Airlines? Yeah, people who fly American Airlines, right? I can make it more specific. I can make it from this date to this date or whatever, but people who fly American Airlines, and my sample would be...
ones who get bumped.
No, be careful. Not the ones who get bumped. Anybody that I pick to talk to, right? Because some of them, I want the people that have never been bumped. They have to be a part of my sample too, or else my average is thrown off. Cool. How are we doing so far? And these are things you guys kind of know already. You've seen this kind of in real life. You've seen this kind of thing. It's just that now we have to get a little more technical with the words we're going to use. So population and sample we're going to see every damn where, because it's the main way we get data for statistics. If my population was you guys, then I probably would just talk to all of you, right? I wouldn't have to take a sample, would I? True? And then I would know the true answer. I wouldn't have to guess. So if I did take a sample of people who parked here, and let's say I get an average, so I talk to people and say, it took me about 5 minutes this morning, it took me about 11 minutes when I got here, it took me about 2 minutes, it took me no time at all, just whoop, right there, blah, 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 blah. And then I take an average, okay, you suck, get out. My average was maybe 6.13 minutes. I have no idea what the true average is, right? Because we'd have to actually do the study. That is my analysis of my sample, right? This is what I got from the sample. These are the answers from the people. So this here, this is interesting. That tells me something about the sample. What did I want to say something about? Why did I take the sample in the first place? I want to say something about these guys. Can I then say, okay, it's 6.13 for my population, for everybody? If here's my sample, right? Let's say I got, let's say 100 people. 100 students was my sample, which is actually a decent sample size. And I know it sounds weird that out of 18,000, if you pick 100, that's good, as long as you're randomly selecting them. Then they represent all those different possibilities. That should give you a pretty good sample. Obviously, the larger the sample, the more accurate this, the more I trust this. Cool? But you don't have to have a terribly large sample to actually trust this pretty well. In chapter 7, we're going to see that in the math. In fact, don't you all the time, when you see like in a race, in a political race, and they say, or even like a proposition, like 40% will vote for the proposition, 44% will vote against it. What do you always see at the bottom of the screen? Plus or minus 4, plus or minus 3%. Did they just throw that up there saying, we're not really sure, let's cover our ass, let's put plus or minus? In chapter 7, we're actually going to see the equations that come out to that exact number. And they should be based on how large the sample was. The larger they take of a sample, the less uncertain they are. They can say plus or minus 2, plus or minus 1, because they took a bigger sample, right? So that would actually be decent, to tell you honestly. All right, how are we doing so far? I mean, I'm throwing a lot of stuff at you, but this is the basics. So this is actually given a name. This is the number that came from my sample, so it is a statistic. Yes, the word statistic actually is used in statistics. You've always heard about don't become a statistic. Well, this is what it is. It tells you something about the sample. And notice something really nice. S. The statistic talks about the sample. Now, what I want to say something about is the corresponding average time for this population, right? That's what I really want. I don't have time to get it. Can't talk to everybody. But that would be the parameter. So the parameter talks about the population in the same way that the statistic talks about the sample. That's silly. Which one of those do I normally get? Can I put my hands on? Statistic. And then we would say, in chapter 7, we'll learn how to do this. We can say 6.13, give or take 2 minutes for the parameter, right? That would be like chapter 7. You guys kind of with me? So it's probably 6.13, but it could be off by about 2 minutes or something, right? And we'll actually get the equations that will give me these numbers in chapter 7. Okay, cool. Maybe. So if somebody told me 6.13 minutes, give or take 10 minutes, I'm like, well, that sucks. You must have talked to 5 people. So I can kind of get a gauge from how far off they think they are. That kind of tells me how many people they talk to. So if they say give or take 30 seconds, I'm like, holy crap, you must have talked to a lot of freaking people to get that precise. Okay, good. I got it. Most of you guys are at least pretending to know what the hell I'm talking about. All right. Cool. Blah. I'm sure I hit all the highlights here. So a couple things that are in section 1.2, and that's actually what we're talking about right now is section 1.2. There's a couple of questions that are more common sense questions, which students don't like a lot in classes that they're not really comfortable in because you might not know what common sense means in statistics. So let me give you an example. Can you tell me if this is impossible, possible but really not likely, or very likely? You with me? So tell me if it's impossible, possible but it's probably not going to happen, or it's probably going to happen. It's very likely. Thanksgiving Day will fall on a Monday next year. Impossible, right? How are we doing? Because Thanksgiving is always on Thursday. While driving through a city, Mario Andretti arrived at 3 consecutive traffic lights, and they were all green. Possible, and is it likely or unlikely? Likely. Now, if you're a cynic, if you've gone through a lot of red lights just to get to school today, you might be in the mindset to say, ain't going to happen. right? But that's actually likely. Right? While driving to his home in Connecticut, David Letterman was ticketed for driving 205 miles an hour on a highway with a speed limit of 55 miles an hour. Unlikely. It's not impossible, because David Letterman makes a lot of freaking money. I'm sure he has a car that can go that fast. So it's possible, but very unlikely, I would hope. Right? It's not going to happen. You don't see it all the time. All right, so that should be pretty straightforward. That should be pretty easy, right? Thank God. We start us off nice. Then we have a couple of things about, looking at some data and how much do you trust the source. So if the Federal Trade Commission found some data, a little mini earthquake. The Federal Trade Commission found some data. You're not the best thing, are you? All right. Would you trust that data? Do you know what the Federal Trade Commission is? If you don't know what it is, do you kind of know what's it a part of?
Sounds important.
Federal Trade Commission, so it's a part of the government. So what's really interesting is, that's actually a question out of the book. I always can tell people's opinions of government based on the answers to that question. Actually, it would be likely that that data can be trusted, right? If you're a big conspiracy theorist and all that kind of business, you might think, oh, they're all against it, right? Which is really interesting, but it's unlikely that's true. I'm not saying it's impossible, but it's unlikely that that data would be skewed. It's likely that it's good because they have so many people looking at them, analyzing their data. They almost have to be right, right? So it's likely that they're good. Okay, cool. Section 1.2 shouldn't be too evil yet. Cool. Okay. So tell me this. You can actually answer this question already. Tell me, is this a statistic or a parameter? So remind me, what's the statistic come from? Sample. And a parameter comes from a
Population.
That's cool. It didn't happen often enough in math where the letters match, right? It's like, make that happen more often. Is this a statistic or a parameter? Among the senators in the current Congress, 44% are Democrats. So did they take a sample of the senators? Among the senators in the current Congress, 44% are Democrats. So I really like to ask this question first for one reason. 44% itself is not a sample, right? How did they get 44%? Where did that number come from? Who did they have to look at? Everybody. So that 44% talks about everybody. If they only looked at the Democrats, here's the silly side. If they only looked at the Democrats, what percentage would be Democrats? 100%. So to get the 44, they had to look at everybody. Therefore, it is a parameter, because it's talking about the whole Senate in this case, right? Blah 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 blah. The author measured the voltage supplied to his home on 40 different days, and the average value was 123.7 volts. Yeah, see now statistics just jump out at you, right? Populations, normally the key word is all. Very often they'll say all students say that the average grade is this. Well, that's a freaking parameter right there because you talk to all students. If they say 80 selected students, well, that's a freaking statistic. You're talking about a sample you took, right? So it just kind of jumps out at you. Blah, 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 blah. Oh, cool. All right. Ooh, let me ask you this. You can answer this too. And this one, this is section 1.3, the last, like 29 through 32. Everybody misunderstands the directions. They're not asking you if it's a sample or a population. They're asking you, tell me both the sample and the population, right? So tell me both the sample and the population. A Gallup poll of 1,012 adults found that 9% of them said cloning of humans should be allowed. So what's this? Now be careful. See, that's the 44% Democrat trap to fall into, right? How did they get that 9%? by looking at the 1,012 adults, right? And was that a parameter or, and actually I left out some words here that actually would help you out, sorry. A Gallup poll of 1,012 randomly surveyed adults found that 9% of them said cloning should be allowed. So what's your sample? 1,012 adults, right? It can't possibly be the 9%. Because how would you even know to pick them to be your sample? You only knew that they were them once you talked to everybody in the sample, right? So what's the 9% actually? I like it. This is statistic, right? It's hard to say sadistic sometimes. Statistic. And what's the population now? That's where people get freaked out. So a Gallup poll of 1,012 randomly surveyed adults found that 9% of them said cloning of humans should be allowed. All adults. And they don't get any more specific. I don't know where these adults are. Probably in the U.S. because the Gallup is a U.S. organization, even though sometimes they do talk about other countries. But since they don't say, all we can say is it seems to be all adults. Cool? Okay. So a lot of times you have somebody do a bad sample. So their intended population might be California. But what they end up doing is they go to Fashion Valley Mall and they talk to people there. Did they hit their intended population? Hell no. Right? They might have gotten some people that were tourists, but can they say for sure that they really randomly selected people from California? Obviously not. We call that a convenience sample. It's very convenient to get it, but it sucked. Okay. How are we doing? Oh, cool. All right. I think that's plenty. So we just finished section 1-2. So who can tell me what that means? Homework 1-2 is due Monday. Cool.
Tuesday.
Due Monday or
Tuesday, sorry. Tuesday. I don't teach too many Tuesday, Thursday class.